Good evening, everyone. My name is Margie Kershaw, and this is my presentation, Big Data in Archives. Is it the future of access? For decades, archives have been contending with an ever-increasing influx into records into their institutions. Digital records have created an even bigger explosion of data, which may leave some repositories struggling with preserving and making materials accessible. Fortunately, there have been several technological breakthroughs that can conceivably make description and access to this mountain of data possible. There is a wealth of computational promise that recent projects have applied to cultural materials. Recent literature describes a wide array of big data related capabilities that have the potential to assist archives, librarians, historians, and others in digital humanities with analysis and access to volumes of more digital or digitized data. This need for assistance and interoperability has long been the focus of digital initiatives. The ability for archival information to be widely accessible between institutions and across the globe is a goal that has been a primary consideration for the profession for at least the last 2 decades. For example, Open Archives Initiative is a protocol for metadata harvesting that would increase institutional operability. Although it's not as advanced as big data technologies, OAI, which is even after 2 decades still a developing protocol, allows for structured metadata in a variety of schema to be mapped and then placed into a form of XML to be harvested and rendered interoperable among institutions. Several projects illustrate the potential of big data to significantly impact accessibility of archival materials via interoperability and description, such as linked data, machine learning, and blockchain data mining. Linked data has the potential to significantly increase visibility of archival and other cultural materials on the web. Rosmani and Goldberga in 2020 studied the potential to link entities for identification of cultural heritage documents. In their research, they developed an annotation tool that effectively links together material from different institutions, and they use controlled vocabularies, RDA, and IFLA library reference model in their annotation tool to link data from a variety of cultural heritage institutions using a dataset comprised of materials related to 2 Latvian poets. They were able to establish linking potential that shows the ability to make a visible, broad range of entities and hierarchical relationships among various types of cultural heritage material. Their 2-part research project exemplifies the recent strides made in data analysis for this project as well as for future use. It enables content-based data extraction that can be used to coordinate content profiles among institutions and related but different materials. While the major focus of linked data projects has been on accessibility, machine learning projects are more applied to description of archival material. In 2020, the author Hutchinson provided a valuable analysis of the tools that machine learning can provide to archival processes. Machine learning includes several types of operations that Hutchinson described, and large collections, especially digital ones, have posed problems in description due to their sheer size. Various machine learning tools can be used to categorize, identify, and process born digital collections. Some of the tools that are available now are not necessarily machine learning, but they do have some capabilities. As you can see, there's a list of tools here. This is EPAD. EPAD is an open source tool for archives available through Stanford Libraries. It is available for download. It has been in development since 2010. It's currently in stage 5 of its development, and it does have machine learning capabilities, although some of the other ones listed here, BigCurator is for preservation-based tool. And certain things like Archivematica, which is not machine learning, but these are some of the more recent tools that are available to archivists. Blockchain is the same technology that's used to mine cryptocurrencies such as Bitcoin and Ethereum. And how it works is that each time there is an interaction, an electronic interaction, a little hash, what they call a hash ingest, is created and attached. So it works kind of like a timestamp, and that is valued to ensure the authenticity of records. As early as 2005, the National Research Council advocated for using the blockchain hash as authenticity proofs for archival materials. As you can imagine, there are just so many different brand new or evolving technologies that can have a serious impact into archives. But there comes definitely along with some opportunities and challenges. Some of the opportunities is reducing the backlog. The speed of processing can help influx with our archival records. Bulk processing allows machine learning to categorize and describe and organize and classify different collections. Deeper description can be attained by linking the various data, so you end up with more instances of authors and events and people. So it's just so much more potential for greater understanding. And of course, interoperability adds to the global knowledge base. However, some of the challenges. Pre-processing of data. A lot of these tasks require the data to be consistent. And as of course we know, the archival materials are often not consistent at all. Machine learning processes require training sets, so they have to train to say what is the good data, what is the bad data, and a lot of times collections are just not big enough or not homogeneous enough to do that. Sometimes some of the machine learning processes are not compatible with XML, and some of them cost thousands and thousands of dollars to implement. Expertise in big data for many archivists is completely out of reach, and there is a lack of off-the-shelf tools for specific tasks. To that end, one group of authors that I studied had a project using deep neural networks. And they insisted that people in humanities and people in the archival field it's an absolute imperative, they need in their training to have things like multivariable calculus, linear algebra, probability, statistics, mathematical optimization, unsupervised machine learning. But fortunately, you don't have to have them in a theoretical, just at an application level. So if you thought EAD was hard to learn, they think we should add all that. Many of the recommendations that were made that were consistent throughout the literature is that need for standardization. Standardization is going to be the key to making many of these tools and processes that big data does have to offer, is to standardize how metadata is created and how we manage the tools that we have now. Another thing that many of the literature has suggested and that I completely advocate for is collaboration, not just working on projects, but interdisciplinary collaboration on a deep level that will get computer scientists invested in what they are facing as well as an issue for the future of their resources and their records. So if we can collaborate with computer science students and departments and digital humanities, that we have a lot better chance of making some of these great tools that are becoming available a reality for archives. Thank you so much for watching. and a short bibliography for the project.